Okay, the function h satisfies this equation whenever x is not 2. So for all x's except 2. It is known that this limit can be evaluated using L'Hopital's rule. Use the limit of h as x approaches 2 to find f of 2 and f prime of 2. Show the work that leads to your answers. I have to be honest, when I read this problem, I drew a big blank. I just could not see. It was so different than anything I've seen in 20 years of the AP test that I immediately moved on to the next thing. You do not want to get stuck, but I will do my best to talk you through this. What they were hoping you would notice is because h, this is a lot of clues you have to put together, because h is differentiable, that means h is continuous. Because h is continuous, let's pause a second here. Okay, so because h is continuous, I have this information on my golden notes, which means I know the limit as h approaches 2, not h, sorry, x. The limit as x approaches 2 of h must equal h of 2. And they told me in the beginning h of 2 is 4. So that means I know the limit as x approaches 2 of this big equation for h that limit's got to equal h of 2, which is 4. So this limit has to equal 4. But they said that the limit can be evaluated using L'Hopital's rule, which means that if I were to plug in, if I were to try to find this limit, I'd be plugging in close to 4 here, close to 4, close to 2 because the limit is 2. And as I plugged in close to 2 in for this x, the numerator would be getting very, very close to 0, which means for L'Hopital's rule to work, the denominator would also be having to get close to 0. All of that leads you to the conclusion that 1 minus f of x cubed would have to equal 0, which means, and that's at x equal 2, which means this f of 2 thing is going to have to end up being a 1, so that 1 cubed is 1, 1 minus 1 is 0. Okay, again, I found this problem to be impossible without the scoring guide. I maybe would have been able to figure it out with some time, I don't know. But definitely on the AP test I would have skipped it. They gave a point if you got this far. They gave a second point if you found this. Now I do believe that if you could somehow deduce this to be true, they might give you that point anyway, even if your work didn't reflect the fact that you identified that this limit was going to have to equal 4 because of the fact that h was continuous. But so far the problem, we've earned 2 points. Now we're supposed to find f prime of 2. So now when finding f prime of 2, we take advantage of L'Hopital's rule, which is the limit as x approaches 2 of this ratio that limit has got to equal this limit. take the derivative of the numerator, which is going to be just 2x, and the derivative of the denominator, which is going to be 0 minus, bring down the 3, multiplied by the f, that gets squared, that gets multiplied by f prime of x. So per L'Hopital's rule, this limit has also got to equal 4. Because remember we showed in the first part that because h is continuous, we know that the limit as x approaches 2 of h must equal h of 2, and they told us that h of 2 had a value of 4. Thereby L'Hopital's rule, this limit of the derivative of the numerator divided by the derivative of the denominator must also have a value equal to 4. So they give us one more point for recognizing this L'Hopital rule connection. And now we can say, okay, if I were actually trying to find this limit, I would be thinking what's happening when x is getting close to 2. So when x is close to 2, the top gets close to 4. So let's see. So this limit, let's do a little arrow here. This limit's going to equal, top's going to get close to 4, the bottom's going to get close to -3. What happens to f when x gets close to 2? That gets close to, sit up here, right? Come on, scroll up. Oh, we already found f of 2. That was silly. That was what we did a little bit earlier. Right here. So f of 2 is 1. So that's going to get close to 1. And then we're trying to solve for the f prime when x gets close to 2. But all of that's got to equal 4. Well, that means this has to equal 1. So solving that equation, -3, 1 squared is 1, times f prime of 2, all of that has to equal 1. Therefore, f prime of 2 must equal -1/3. And they gave one more point for doing that. So again, one thing to remember, again, I would have skipped this problem. If I had time, I'd come back and try and get whatever I can on it, but I would definitely not want to work this before I earned other points. Remember, this is the exact problem that my students took on the AP test last year, and I've mentioned this all year long, but just as a point to give you some confidence, last year, 91% of all students who came out of my classroom, they passed the test. 70% of those who passed got a 4 or a 5. And also, the students from my classroom scored higher on the FRQ than on the multiple choice. So even with a problem like this, where I really suspect most just skipped it and got nothing for this problem, even though there were 4 points possible, they still did outstanding. The national pass rate, I believe, was 58%. So have confidence that this strategy of skipping really, really works. You want to keep moving. Don't get stuck.